Hello. In this lecture, I'm going to explain to you the switching concepts. So this model will, as I told you, will explain to you the switching concepts. And after this lecture, we will learn how the switches will, based on we call MAC tables. How do these switches take decisions to forward data or data frames? Okay. So first we will learn what's frame forwarding, and as I told you, we will learn how the switches forward the frames based on what information. How do they take the decisions to switch a given frame data to a destination, for example? And we will understand and compare what's a collision domain compared to a broadcast domain. First part is we'll be talking about frame forwarding. For example, in any switch, you will find two interfaces. Entering interface that enters the frames to the switch, and the outgoing interface. So the incoming interface where frames enter to the switch, we will call it ingress, and the exiting interface, we will call it egress. Okay. These two terms will be accompanied with any switch that take decisions for forwarding data. So a switch forwards based on the ingress interface. The switch will look from which interface, ingress interface, that a frame comes, and also the destination MAC address. Okay, so whenever the switch want to forward packets or frames, he will take the decision based on the ingress interface and the destination MAC address within this frame. So as mentioned here, a switch uses its MAC address table. It uses as routers as in routers we use routing tables. In switches we use MAC address table to take the decisions of frame forwardings. So you should put in your mind that if, for example, a switch will receive this message from port 4 here, for example, it will never forward the message to the same port, even if this switch does broadcast. It will never forward the message to the same port that it has received this message from. Okay? So the switch MAC address table, what does this mean or how does it help? Basically, a switch will use the destination MAC address to calculate or to determine the egress interface. So from the MAC address, or using this MAC address, the switch will find the exiting interface or egress interface based on the destination MAC address. So before taking this decision where to send this frame and to which interface, he should learn the interface, the number of the port number of this interface. Okay, and as you know, or I have already explained to you, that the switches use MAC address table, which we call them content addressable memory, to update these tables, to add or to record these source MAC addresses that are coming to this switch. with port number. Before we have added, for example, for the routing tables, we were adding the source IP and these things, and we match the destination IP with the existing IP within the routing table. Here, the switch will use a MAC address table, okay, and any frame that comes to the switch will record the source MAC address of this frame into this table, MAC address table, which we call content addressable memory or CAM table, with the port number it was received. So we will record two things: port number that it was received and the source MAC address. Uh, how the switch learn and forward frames. Basically, the switch use two things or two consecutive steps that help the switch to take decisions how to forward these frames. First step, it's learn, and the second, it's forward. And in both cases, in the first one, learn, it examines the source address. So it works on source address. So when the switch will receive the frame, it examines within this frame the source address. It looks the MAC address table. If this source MAC address is not in the table, the switch will add this source MAC to the table, and then resets. And in the second case, if this source address is in the table, if the switch will find the source MAC of this frame is in the table, he will reset a time for 5 minutes. Okay. The second step, this phase or this step, we call it learning. It learns about the source MAC addresses. Okay, and it learns if this source MAC address exists or not in the table. The second step is forward, and we call it forward, and the switch will examine the destination address. So there's two things. If the destination address is in the MAC address table, it determines the port number for this destination MAC. It determines from which port number, and it will forward this frame through the specified port to the outside. However, if the destination address it's not in the table, destination not source, destination address is not in the table, what should do it? Basically, the switch will float all the frames of this specified frame. It's like broadcast all the interfaces. It transmits these frames in all interfaces of the switch except the one that it has received the this frame from. For example, as I told you here. Okay, if the switch will receive from port 4, and imagine that the switch didn't find the destination address in the MAC address table, then it will flood all this frame in 1, 2, 3 port and 5, 6, but doesn't send it to or flood it at port number 4. This is the point. And also to do decisions, basically the switch use two forwarding methods: store and forward switching and cut through switching. However, Cisco routers use Cisco routers use the first one, store and forward switching. What does this mean? It means that the switch will receive all the frame, entire frame, completely. If it's 100, if it's 512 bytes, for example, it will receive all the frame. Then it will check this frame. Okay, it will, for example, checks for errors using the frame check sequence. And if it finds this switch, for example, there's too much errors or some errors, he will drop this frame. Only valid frames can be forwarded. So this will take time because the switch will check all the message, all the frame parts, the forward, the FCS, the frame check sequence, or CRC, or the error correction codes, all this stuff. Okay, he will check. If there is no errors, he will forward. If there's errors, he will drop this frame. So only valid frames are forwarded to the destination. However, for the cut-through switching, it only reads a part of this frame. It only reads the destination address, and it doesn't check for errors or these things. So forward the frame immediately after determining the destination MAC. What's important in this case or in this method here is to only know the destination address. If it knows this destination address, it forward immediately the frame, okay, to the MAC address, destination MAC address. And for sure, he will deduce from the MAC address the egress port, to in which port the switch will transfer this frame. So the switch start forwarding immediately after reading the destination MAC address. It doesn't wait for the entire frame. It doesn't wait. But here, the store and forward switching will receive the entire frame. Okay? So the switch receives the entire frame first, then start to check. Here it doesn't wait for all the entire frame, but